Hey guys, welcome back. In this video, I'll teach you about integration by trig substitution. So the first thing that you guys have to do in any of these integral problems is identify what type of problem it is. In this problem here, I have the integral of 1 over 9 plus x squared. That's beautiful because it's an arctan. Arctan has this special formula that is 1 over a being the square root of 9, arctan u over a. 1 over a arctan u over a, where a is 3 and u is just x. It's the square root of those. That's great. You're finished. In this formula here, this is an arcsine. Arcsine doesn't have a 1 over a. It's just arcsine u over a. Again, where a is 4, the square root, and u is x. So, how do we recognize when we need to use a trig substitution? Well, trig substitution problems look like these guys up here. They look like them, okay? But there's something off. So instead of having 1 over 9 plus x squared, I put the square root in there. That's a trig. Instead of having 1 over 16 minus x squared, I might have x to the third. So that's a trig. You can't use a u sub here because of this part won't cancel that part out, and you can't do anything about it. So I'm going to show you what happens when there's a plus and what happens when there's a minus. In this video, I will only do the plus so I can make the video short. In the next video, I'll do the minus. When you have something that looks like an arctan, but there's a square root, what you want to do is use the special formula tan squared theta plus 1 equals secant squared theta. So what we want to do in this case is the following. I'm gonna let x equal the square root of this number times tan theta. Okay, I'm gonna put this, and you'll see why I did tan theta. I'm gonna put this in here. So 3 tan theta squared. I also noticed that I left dx, okay? So now I have 3 squared is 9, tan squared is tan squared. Is that good? Now you're going to factor out the 9, and you're going to be left with 1 plus tan squared theta. In that case, I'm going to say 1 plus tan squared theta is this identity secant squared theta. So this is secant squared theta, this is a 9. This is under a square root from the original problem. So 9 becomes a 3, and secant squared theta becomes a secant theta. You can pause the video if you need to. I still have this dx. I need to change dx to d theta in order to integrate. So what do I do with this? In order to change dx to d theta, I'm going to take the derivative. The derivative of x is dx. The derivative of 3 tan theta is 3 secant squared theta d theta. So I'm going to exchange dx with this guy here. Well, 1 cancels out with this one. 1 cancels out with one of these. So I'm left with secant theta d theta. Pause the video. Okay, so I'm going to just erase those so you can see it. Okay, so this simplifies to this. What's the integral of secant theta is the natural log of secant theta plus tan theta. The only problem is my question started with x's, so I need to exchange these guys here. So how do I change that? Well, check this out. If I know that x equals 3 tan theta, then I know x divided by 3 equals just tan theta. So now tan theta will get replaced. So by x over 3. Does everybody see that? Now I need to figure out secant theta. The only way I could figure out secant theta is by making a right triangle. So let me erase this. Once again, this is a video, so you can just go back to the... I'm going to say x over 3 equals tan theta. Tan theta from SOHCAHTOA, tan theta is opposite over adjacent. a squared plus b squared equals c squared yields my hypotenuse to be x squared plus 9. So what is secant? Secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then we're looking for hypotenuse over adjacent. And then you can just leave your answer like that, and that's done. Okay, so that's how you do trig substitution. You just have to make it find this piece of it. So pause the video, but I just want to show you one thing. The reason why I chose 3 is because I need it to be 9. If there was a 4 here, then I would choose this to be a 2. If there was a 16, then I would choose it to be a 4, and so on. And the reason why I chose tangent is because when there's a plus sign, you want this. When there's a minus sign, guys, you want to use sine. So come back for the next video so I can show you how to do this problem here. Have a great day.